Okay, here is another example of the static analysis, and essentially we are going to analyze an I-beam. We have an I-beam with the profile dimension that has been provided, and then the problem asks us, this is a 600 millimeter beam, and the problem asks if we apply a 8,000 kilogram of force here in the middle of the beam across a span of 50 millimeter, which is a very tremendous loads and weights, while the two ends of this I-beam is fixed, meaning that it's going to bend from the middle. The question is this going to survive from that excess load? And what is the degree of safety or factor of safety with respect to this load? Okay, let's get it started. Please open off of the shared material a file with beam, which it's already modeled in there is a sketch that already modeled the profile of that beam. If you want to see that, there's a profile of the beam with those information. It might that previous drawing might not give you all of the dimensions, but it's been fully defined. And now the fillet and everything applied, so the part is ready for the calculation. Before doing that, we are going to specify some areas. According to what I explained, we need to define an area that the force is going to apply, and then the area that the beam from either end is going to fix. And what we have learned so far, when we are defining a load or a fixture during the static analysis, we have to give SolidWorks a face to as an area of application of the force or the area of the fixture. Therefore, we have to define those faces. It's better to define those faces before we jump into the analysis. So if this is top of the beam, I click on it, go to the sketch, and I have to give them the area. And you remember it was based on that information, it was 50 millimeter across, in the center of the beam for that 8,000 kilogram. So I'm going to select a center rectangle, hit this center, and I'm going to coincide with this edge. I'm going to give it a dimension of 50 millimeter. Okay, so it's been fully defined. Then I'm going to go back, and now I have a sketch on this face. In order to define we are going to create a face out of it. Instead of going to the surfaces, which essentially you are not going to create a new surface, because then that count as a different body of in addition to this rigid body. Instead, we are going to go to curve all the way at the end, and there is a command called split line, and we have used this one when we are trying to project a doing the projection across during the surface modeling. And this is a very simple projection. I'm going to project this sketch over this face. Sketch is selected, I give it the face, the projection is selected, and hit OK, and it's going to give me an area, and this area is not going to change the geometry of that. This doesn't have any thickness or anything. This is just a definition, an area that I defined for my study. On the bottom of the beam, I'm going to do the same thing, but we know that we have to give them two areas in here, and then I'm selecting this corner, coming here, two rectangle, and I would like to define the width of that as, let's say, 40 millimeter. So this is the area that the I-beam would be fixed against. So 40 millimeter here, sketch fully defined. Going back while the sketch is selected to save some time, going to split line, and I'm going to give this surface its projection, and I have now two other surfaces for my fixed area. Isometric view, we can save it, and essentially I'm going to here, and I would select a simulation, going to new study, it would be static, hit OK. Static 1 is going to start, and then we can let's save it. We can start steps. First is about the material, so you see that only one solid body has been identified. Those surfaces that we defined has no impact on that. Right click, select the material, and then from the material that has been selected, let's select for example A36 structural steel, hit OK. So we have the material. We skip from connection. This is a part, not assembly. And now for fixture, right click, going to fixed geometry. And then for fixed geometry, I'm going to give that two areas that we have modeled. Hit OK. Going to external load, that would be force. And then it asks us for this face and 8,000 kilograms. So essentially, so this is a Newton, but I'm going to go to metric, and it would be 8,000 kilogram force. And it would say, you know, no reverse direction, is downward, is good. So hit OK. Should have that. We can go create mesh, and then we can like give it as default, or we can slide it in either way. Now a mesh is going to create, and it would appear, you know, that the mesh is having it's fully grasped that you know, geometry is going to get finer detail around the corners and capture that complexity. Now hit save before conducting the study. Is very common that it crashes sometimes, the solver crashes, and you may lose your progress. So if I run the study, I should see the result, and we're going to discuss to see if the beam is gonna survive against that load. And here is the exaggerated deformed result. We can keep it that way. And now we are seeing that this material is barely survived, very close to this calculation. Now let's select a different material here and see what the result would look like. Okay, for changing the material, we wanted to consider a scenario that instead of A36, we are going to see what if this beam made out of the stainless steel. So if I'm going back to apply the material, and I'm going to change it from A36 to 304 stainless steel. Okay, and SolidWorks will see that the result is not valid anymore because it belongs to the previous study. Let's run it. Okay, now you will see that something different has happened. Now this graph shows that the yield strength of this material is now right over here. It means that the part until this point is the one that will be okay, but there are some areas, particularly here, or maybe underneath, no, that would be here only, that are gonna fail. The material cannot withstand this this force when it's applied with this configuration. Now we can actually define it, that what does that area look like if we wanted to see as a part of like an entire geometry, get that. If you right click on this chart, and so first if you wanted to see an animate of what is this stress would look like. It creates the bend in the center, and you will see that it's gonna bend at some point. It's gonna fail. But this wasn't the one that I'm trying to show here. If you right click on this and you go to ISO clipping option, you will see that the area that the ISO 1 is selected, you will see that it's gonna shift, and it's going to show the areas from this point all the way up. You can reverse it, meaning that I want to interested to the area from the bottom of this up to this value that I'm defining, right? Which would be like the rest of that. But let's say I want to see all the materials that are in excess of this yield strength. Let's change the instead of Newton per square meter, which is derivative of this MMGS system, let's select it based on a PSI. I'm going to change it by PSI. Every value would be PSI, and you see that this is almost 3 to the power of 4 yield strength. So if I'm going to ISO clipping, and then here I wanted to put exactly this yield strength, that is essentially 29999 section 4, right? That would be the one that it has, and then you will see that that's right on the yield strength, right? And it's showing from this point all the way to top. That is the area of the failure that you can identify it. Okay, that would be the ISO clipping that I had it. So if I don't want it, I can go back to the ISO clipping, and for example, I would put it on, believe here, right? Which is all of them would be the one. Okay, so, and this will conclude that of this failure of this component. Last example that I would like to go over would be about an assembly, so stay tuned. Let's save and exit out of the part.